Hi, I'm Emeline Sofia binti Sarudin.
Hi, my name is Nurul Anis binti Aslan.
Hi, my name is Sean Lee.
Hi, my name is Mainder Loganathan.
Hello, my name is Noel Anaheri, and today we will be talking about our Chemical Engineering Department Integrated Design Project for September 2021 semester. So first of all, we will be talking about the introduction for the course subject CEB 1043, which is Principles of Chemical Engineering, or YAB 1063, Material and Energy Balance. So first of all, we will explain about the objectives of this subject. The first objective will be to define and analyze the conservation equations for each given process so that each student will be able to interpret available data and apply appropriate equations for determination of flow rates, compositions, and temperatures in a process flow sheet. The final objective that we plan to achieve for this subject is to perform material mass and energy balance calculations for a given process. So onwards towards the introduction. For this particular subject, we are introduced to two main streams, which is the chemical industries and chemical engineers, which comprises of the companies that introduce industrial chemicals. So it is central to the modern world economy that chemical engineering department converts raw materials such as oil, natural gas, air, water, metals, and minerals into more than 70,000 different types of products. So a plant, which is part of the chemical engineering process, consists of several process units such as distillation columns, reactors, preheaters, tanks, etc. These process units relate to pipelines and become a continuous flow of reactors to products. So each plant can be represented by a process flow diagram showing the detailed flow of processes as well as process and instrumentation diagram, P and ID, with the control and strategy mechanism. On the other hand, a chemical engineer is a profession in which one works principally in the chemical industry to convert basic raw materials into a variety of products and deals with the design and operation of plants and equipment to perform such work. So onwards to the introduction for course code CEB 1053, Chemical Engineering Fluid Mechanics. So the objectives for this particular subject is to apply the knowledge of mathematics, science, and engineering fundamentals, as well as an engineering specialization to the solution of complex chemical engineering problems, and to identify, formulate research literature, and analyze complex chemical engineering problems, reaching substantial conclusions using principles of mathematics, natural sciences, and engineering sciences. So the overall introduction for this subject is to allow the students to design solutions for complex chemical engineering problems and design system components or processes that meet specified needs with appropriate consideration for public health and safety, cultural, societal, and environmental considerations. By applying reasoning informed by contextual knowledge to access societal, health, safety, legal, and cultural issues, and the responsibilities relevant to professional engineering practices, and apply ethical principles and commit to professional ethics and responsibility, as well as the norms of chemical engineering practices. Next, we should be able to demonstrate knowledge and understanding of engineering and apply management principles and apply these to one's own work as a member and a leader in a team to manage projects and in multidisciplinary environments. And finally, we should be able to communicate effectively on complex chemical engineering activities with the engineering community and society and function effectively as an individual and as a member of or a leader in diverse teams. So we will now be moving on to the second chapter of our project, which will be related to CEB 1043, Principles of Chemical Engineering. So what we have here is the process flow diagram for the production of ammonia from natural gas. So in this case, we're producing ammonia from the methane gas, CH4. And as you can see, there are various processes going through it to perform the production of ammonia, where first off, it goes off towards the production of the synthesis mixture, and then finally the production of ammonia. So there are various different steps in order to achieve this. We'll go over that in the next slide. So these are the processes that are involved in a short and explainable sense. So the first process will be desulfurization, where disulfur compounds must pass through a desulfurization unit, where the desulfurization of both natural gas and naphtha takes place in two steps, which is hydrogenation and adsorption. The next step after that will be the primary reformation, in which the reforming section, the desulfurized catalytic reforming of the hydrocarbon mixture mixed with the steam and the addition of air converts gas into ammonia synthesis gas. And the steam/gas mixture is then heated to a further 500 to 600 degrees Celsius. And next will be the secondary reformation, in which the reforming section, the desulfurized catalytic reforming of the hydrocarbon, is also steam and addition of air convert gas into ammonia synthesis gas. Basically the same process, just that performed a second time. Now onwards to the production of ammonia. First off, we have shift conversion, where the gas is passed through a bed of iron or chromium oxide catalyst at around 400 degrees Celsius, which is a high temperature shift. This is the first step of the process where the gas will be released at the outlet stream containing both CO2 and CO. In both shift reactors, all CO is converted to CO2. The second step of this process is carried out at low temperatures around 195 degrees Celsius to achieve equilibrium conversion. So the catalyst used for this is mainly copper. The next step is the CO2 removal. CO2 will then be removed by either absorption in hot aqueous at ethanolamine solutions at high pressure. So this is to ensure that the solution is hot to increase the rate of absorption. The second to last step is methanation, where residual carbon dioxide is converted to methane, which acts like an inert gas in the ammonia synthesis loop. The small amounts of CO and CO2 must be removed by conversion to CH4, since both CO and CO2 act as poisons for the ammonia synthesis catalyst. And finally, the Haber-Bosch process. This is mostly for modern ammonia plants, where they use centrifugal compressors for synthesis gas compression. The synthesis of ammonia takes place on an iron catalyst at the pressures usually in the range of 98.7 to 246.7 atm and temperatures in the range of 350 to 550 degrees Celsius. So those are the steps that are involved for the process flow diagram in the production of ammonia gas.
Alright, so now we come to chapter 3 of our project, which is CEB 1053 Chemical Engineering Fluid Mechanics. So there are two principles involved in this project, which is the principle of conservation of mass and the conservation of energy. So for the law of conservation of mass states that in a chemical reaction, mass is neither created nor destroyed. The carbon atom changes from a solid structure to a gas, but its mass does not change. Similarly, the first law of thermodynamics states that heat is a form of energy, and thermodynamic processes are therefore subject to the principle of conservation of energy. Likewise, heat energy cannot be created or destroyed. Schedule 40 commercial steel pipe is used because this pipe is very tough to withstand any pressure. In comparison to other types of pipes, it's also sturdy and long-lasting. Furthermore, this steel pipe is simple to install and handle, as well as installation and shipping expenses are both inexpensive. The roughness of Schedule 40 steel pipe is low, with a value of only 0.045 mm. Low roughness indicates that less friction loss in the piping to the environment, which proves the efficiency of the pipes. Other than that, these pipes are composed of non-corrosive steel, which means that they will last longer and save a lot of money. 4-inch pipe with a diameter of 0.10226 meter is used, and according to the formula, Q equals to AV, velocity of fluid flow is inversely proportional to area of the pipe. When the diameter of pipe decreases, the velocity of fluid increases while the pressure in the pipe decreases. This will save a lot of time taken for the fluid to flow from one point to another. As for the fittings and valves, in our project we have selected union fitting and gate valves. Union fitting is used to ensure smooth flow of the fluid, providing leak-proof disconnection point in any piping system. It can be installed easily and can connect piping systems to vessels. Slightly rounded edges are used to reduce the turbulent flow and maximize flow through pipe. Lastly, the gate valve is added since the movement direction of ram is perpendicular to the media flow direction. Gate valves are an energy-efficient valve alternative. As a result, as compared to other valves like globe valves, less power is used to open or close the gate valve. Thus, they help in lowering total ownership costs due to their energy efficiency. So for the Haber process, this is the process where ammonia is being produced. Ammonia is manufactured using what we call this, as you can see in the slide, the picture, Haber process. This involves a reversible reaction between nitrogen and hydrogen. So as you can see, we already included the chemical formula in it as well. Nitrogen extracted from the air and hydrogen obtained from natural gas are pumped through pipes. The gas are passed through 4 bits of catalyst. Passing through a tank containing an iron catalyst is used in the process, and the whole procedure is conducted by maintaining a temperature of around 450 degrees Celsius and a pressure of 200 atm. While each pass has a varied amount of conversion, unreacted gases are recycled. After going through the heat boiler, the ammonia gas is then condensed into a liquid solution, which is collected and kept in storage containers. Lastly, the unreacted nitrogen and hydrogen are recycled back into the stream, and the process continues. Liquid ammonia is stored either at ambient temperature under high pressure or at negative 33 degrees Celsius under atmospheric pressure. Out of all the dimensions, a vertical cylindrical tank is the best shape and easier to handle for an ammonia storage tank. Due to the benefits of conserving steel, lowering floor space, improving operation management, and minimizing storage tank attachments and pipeline length, huge storage tanks are commonly used to store various petrochemical products. The cylindrical tank can hold a lot of ammonia and can resist hydraulic pressure changes without distorting and more economical. The tank's holding capacity must thus be substantial to store a large amount of ammonia because ammonia storage may deplete over time. The tank must retain a substantial amount of ammonia before it can be refined. As ammonia is corrosive, the storage tank must be composed of robust materials like steel and concrete that can withstand the corrosion. The interior pressure for cylindrical tank also is lower when it's compared to cubical or other shapes of tank. As a result, the tank can keep the ammonia for a longer period of time. And for our conclusion, Chapter 4, Chemical Engineering is a field of engineering that deals with chemical production and product manufacturing using chemical processes. This involves developing machineries, methods, and procedures for refining raw materials as well as combining, compounding, and processing chemicals to create useful daily products. The process flow diagram is the primary technique of describing the process and design information, which makes it a fundamental component of process designing. The process flow design is commonly used in the industries and plays an important role in chemical engineering. Other than that, the basis of accounting for the inputs and outputs of a process are mass and energy balance, as what you can see in our report. One of the physics fundamental rules is that mass cannot be created or destroyed, implying that mass is conserved. The law of conservation of energy is equally important. Energy can take on several forms, but it cannot be generated or destroyed. An energy balance considers the energy input, output, and consumption, and generation in the process or stage. In addition to that, energy balances are used to examine the many phases of a process, as well as the entire process and the entire production system from raw material to completed product. Most chemical processing operations are conducted either partly or totally in the fluid phase. The first law of thermodynamics states that heat is a form of energy and thermodynamic processes are therefore subject to the principle of conservation of energy. This means that energy cannot be created or destroyed. Furthermore, to obtain greater market share and empower their team, a good engineering team creates products at the pace of their customers' requirement and command. And that's all for our project. Thank you.